right, let's talk about cotangent, huh? Huh? You can look at all this stuff. It's very similar to all the transformations we've been doing. But the important thing to remember is cotangent is the reciprocal of tangent. So let's take it back to the unit circle, shall we? We shall. Thinking about the unit circle, we got pi over 2 up here, pi, 3 pi over 2, and 2 pi, or 0. Right? And this coordinate was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So if tangent is always your y over your x, or your sine over your cosine, cotangent would just be the reciprocal. So cotangent will be our x over y. So at pi over 2, if we did our x over y, we're going to get 0. Now with tangent, that was undefined, but now we're at 0. At pi, it used to be with tangent, it was 0, but now if we do x divided by y, this becomes undefined. So at pi over 2, it's 0. At pi, it's undefined. Guess what it's going to be at 3 pi over 2? It's going to be 0 again, because we're going to have 0 divided by negative 1, which is 0. And then at 2 pi, it's going to be undefined again, because it'll be 1 divided by 0, which is undefined. So let's go ahead and mark it off like we usually do. Pi over 2, pi, 3 pi over 2, and 2 pi. If we kick that to the negative side as well, negative pi over 2, it'll follow the same pattern. Negative pi, negative 3 pi over 2, and negative 2 pi. So these undefined spots are going to be vertical asymptotes. So we have one at 0, we have one at pi, we have one at 2 pi. So it happens every pi units here. And of course, we'll have our transformations later. So I want you to remember that tangent graphs, a standard tangent graph, typically went up as it went to the right. Cotangent graphs are just going to go down and to the right. And they've been shifted over half of a pi. Because remember, the asymptotes on tangent were just at negative pi over 2 and pi over 2, unless there was a translation. Now we've shifted those asymptotes over a half a pi. So now they're at 0, pi, 2 pi, and it's the same period, pi over 2. So you find your center point, and then instead of typically going up 1 over 1, we're going to go down 1, right 1. We can go up 1, left 1. So it's kind of just like if we had the negative tangent, but, slid over half a pi. Find your middle. Go up 1, left 1, go down 1, right 1, up 1, left 1, down 1, right 1. Pretty easy. It's like a reflected tangent graph moved over to the right, pi over 2. Cool. All right. Let's try again.